go along. So from last lesson, what I wanted to introduce to you guys was a couple of concepts of like, what is a radian? It's the radius, and you'll find that 6.3 of those will fit around the circle. So really it's, 2 pi is to do 1 revolution, because 2 pi is 6.3. So one of those is 1 radians, and that's what a radian is. So, if it's 2 pi to do 1 revolution, half a revolution would be pi. Therefore, if you did a quarter of a revolution, that would be half on pi. Sorry, quarter. If you only went 45 degrees, that's like a quarter of pi, so that would be pi on 4, and so on. 30 degrees would be pi on 3, because, it would be pi on 6, would be 30 degrees. So we looked at this concept of drawing a line from here out to the edge and here out to the edge, and we did 30 degrees either side from the x-axis. So that gave us 60 degrees. Then what we realized is that we had a length of 1. This is a length of 1, and you realize that this is a length of 1 because it's 60, 60, 60. You've actually made an equilateral triangle. We halved this. When we halve this, that's obviously going to be 30 degrees. We've still got 60 degrees here. We know this is still 1. We know that this is a half because we've halved the length. So the area of this is at 1. That's a quarter. That has to be 3/4. Square root that, it's root 3 on 2. That triangle there gives us exact values, okay? We've got 30 degrees, half, 60 degrees, opposite that's root 3 on 2, and 1. So we've just taken out that triangle. From here, we can see that sine 30 degrees is a half. And the best thing with the unit circle is it's just opposite over hypotenuse, because the hypotenuse is 1. So really, sine is just the opposite length because the hypotenuse is 1. We also realize that cos 60 is the same as sine 30 because it comes from the same triangle, adjacent over hypotenuse. So that means sine 60 is the same thing as cos 30 because it's adjacent over hypotenuse. Sine is opposite over hypotenuse. So we've realized that from these graphs. So on the one below, we can actually fill out what the values of those are. So we know that sine 30 degrees is a half. And we know that cos 60 is a half because of this triangle that we created. We've proven an exact value. We've actually proved this, and this is where it comes from. So sine 30 is opposite over hypotenuse, so it's really just the opposite because the hypotenuse is 1 because we use the unit circle. That's why we use a radius of 1 because it's just the opposite. And cos 60 is adjacent over hypotenuse, so that's why it's a half. Now, how do we get root 3 on 2? Well, that would be cos 30 or sine 60. Because cos 30 is adjacent over hypotenuse, cos 30 is adjacent over hypotenuse, sine 60 is opposite over hypotenuse, and that's root 3 on 2. So, because it's just on 1. So we can go down to our table and fill that out as well. Don't worry if you haven't got this table ruled up yet, we will go through this again later. So we know cos 30 is root 3 on 2 because it comes from that triangle, right? These are the triangles. And this is root 3 on 2. Now, really, in year 12, we'll just expect you to know all these from 0 to 30 to 90 degrees anyway. And that's really what we want you guys to know, is all these values, including tan. Now, tan is sine divided by cos, okay? Is sine divided by cos, because if you think about tan, tan is opposite over adjacent. We'll get to that a little bit later. I'm just going to stay with sine and cos at the moment. But if you think about it, if you say what tan 30 is, well, TOA is opposite over adjacent. So that divided by that is going to be 1 on root 3. Okay, so that's what we can say. So, why we can say tan is sine on cos is because what we need to understand is that really sine is just a measurement of my opposite length. Okay, so if sine is a measurement of the opposite length, that means cos is actually a measurement of my adjacent length. And that's where we are there. And that's something that we're going to go through. Please ask questions if you're not sure. Now, what I asked you guys to do was to form a 90 degree triangle in here, 45 degrees from each side. So I'm going to fill this out and see how we go with this. It's exactly the same proof. These are the only 2 proofs that you need to know to understand the right angle triangle to understand exact values. So there's 45 there and there's 45 here. Together, this will make a right angle triangle. Okay, this has 1. This has a length of 1 because it's the radius of 1. What's this length? Well, we know that this is an area of 1. We know that the area of this square will be 1. So the total area of this would be 2. So the total length of that would be root 2 from top to bottom. Now what we're going to do is we're going to actually split this in half and do exactly the same thing. So we're going to go 45 degrees up, and that should be going straight along to there. It's pretty good. Okay, and then what we're going to do is put this to here, straight down. Okay. I'm going to split it in half like so. This is the other proof of this triangle. Okay, if we split this in half, what do we now know? Well, we know that this is going to be 45 degrees. 45 degrees is the, 45 degrees is the same thing as pi on 4 as well, same thing. And then, oh, sorry, we forgot to do something here. If this is 45, 45, this is a isosceles triangle. That means these angles up here must also be 45 or pi on 4. And this must also be 45 because this is 90-degree right angle, right? So if you turn your head slightly to the right, you can see that that's a 90-degree right angle. So these are 45 degrees, or we could call it pi on 4, either way. So we know this is pi on 4, 45, we've halved it. This also has to be 45. Okay, so we know that this is 1. This was root 2. What have we done? We've halved it. So this is actually now, this length is root 2 and 2. We've halved it. And because now this is a right angle triangle and we've actually made an isosceles triangle there, this needs to be root 2 and 2. Any questions on that one? Please use your microphone if you do, otherwise I'm just going to move on. Okay, I'm going to move on. Feel free to interrupt me. So what do we have from there? Well, we've created a right angle triangle, okay, with 45. That's our proof. So let's fill the details out. So we're just sort of extracting the main information.
Sir,
yeah.
How did you get the side lengths? Like, how did you calculate them?
Okay. Which ones? The very first one?
Yeah.
Yep. Okay. So this is a unit circle. The unit circle means it has a length of 1. Okay. So anywhere from here out has a radius 1. So if you look at the sides here, see how it's got 1. So the radius is 1. Can you see anywhere from there? Does that make sense? So can you see how I got 1?
Yeah. Yeah.
Yep. So 1 and 1, right? If I've gone 45 degrees up and 45 degrees down, that's going to make a right angle triangle in here. Can you sort of see the right angle triangle is there? Like that's the right angle?
Yeah. Yeah.
So if it's a right angle, I can use Pythagoras, right? So we've got a squared plus b squared, which is 1 squared plus 1 squared plus 1 squared, which is 2 squared, right? Which is 2, sorry.
Yeah.
So I know that the area of C is 2. That means the length of this is going to be root 2. So I'm just going to do that again. We have a right angle triangle. You with me? This is 1.
Yeah.
This is 1. Sorry. The length is 1, the areas are 1. So really, if you think about it, that means the square of C equals 2. Yeah. So therefore, the length, so the area of this is 2. So the length of C equals root 2. So what I like to do in my head, what I visually actually do is, does that make sense why it's root 2?
Yeah.
Yeah. So what I like to do is actually, I more see it as the areas of 3 triangles, because what actually a squared plus b squared means is it's actually, this is a squared, this is b squared. And if it's a right angle triangle, that will actually equal the area of this c squared, right? That's c squared. We're talking about the areas. So it's actually 3 squares that adjoin each other that make a right angle. So this is the length A, this is the length B, and this is length C. So what I see when this is 1, I see it as an area of 1. When this is 1, I see this is an area of 1. Therefore, these two areas need to be this area, which is 2. Therefore, the length of this is root 2. So with a typical 3, 4, 5 triangle, that's kind of how I do it. I visualize it in my head, and that helps a little bit with this. So with a 3, 4, 5 triangle, what I see here is I see that this actually has an area of 9. And then I see this has an area of 16. So therefore, these two areas need to add this area, which is 25, right? 9 plus 16 is 25. Well, once I know it's 25, the square root of 25 is 5. And that's how I can actually calculate it, because a squared plus b squared equals c squared. Why they're squares is because if you think about what 3 squared is really like 3 times 3, right? 3 by 3. So the area of this is actually 9. So it actually represents the area of a square. And that's why we call it squared, because it's a square. You can also call it 3 to the power of 2. If you think about 4 to the power of 3, we can actually call that cubed, because 4 by 4 by 4 actually gives you the volume of a cube. And that's why we call it cubed, because the volume of that is actually 4 cubed. Okay, so that would have side lengths of that. So if you have something like 5 to the power of, I don't know, 4, we don't call that like, that's the 4th dimension. So, if you've got 3 to the power of 1, you can actually represent that as, the length of this is 3. 3 squared, I can actually say, well, that is the 2nd dimension, 3 squared, and 4 to the power of 3 is cubed. So that's why we call it squared and cubed. So when I talk about that, if 3 squared is actually the area of a 3 by 3 squared, that means a squared would be like an a by a. The area is a squared, okay? B would be by b. So when I look at, they're saying, hey, we've got a squared plus b squared. This is the area. The area of this plus the area of this equals the area of this. So when I'm going through and doing this in my head on these ones, so I've got 1, 1, 1 for the first one. I see then when I split that in half, I see that this is 1, that's a half. So I see the area of this as 1. The area of this is a quarter, because it's a half times a half, which is a quarter. Therefore, the area of this needs to be 3/4, because 3/4 plus a quarter has to give me 1. Then I square root this, which is root 3 on 2. Similarly, down here, we've got 1, 1 with 45, 45, which makes a right angle. So I see the area of this is 1. The area of this is 1. That means the two areas added together gives us 2, right? This area is 2, this square. That means the length is root 2. Then I can actually halve this. Then when I halve this, I realize, oh, hang on a moment, this actually makes an isosceles triangles. That was root 2, but if you halve it, it's root 2 on 2. And because it's an equilateral triangle, that has to be root 2. Sorry, non-equilateral triangle, it's an isosceles triangle. That's root 2 on 2. That means this has to be root 2 on 2 as well. And that is really pulling out the information there. Sorry, but that was a really good question that you asked. So I just want to go through my thinking and about how I do it so quickly. Does that help you guys a bit? So that's pi on 4 or 45 degrees. I should actually write that a bit better. Zoom in a little bit. So what we want to do is we're just proving the angles here, like where do they come from? So that is pi on 4 or 45 degrees. That means this is a right angle here. And this has a length of 1. So what can we tell you about this? Well, same thing. If I say what's sine 45? Well, in this case, it doesn't matter which sine you look at. Sine is opposite over hypotenuse. Opposite over hypotenuse. Well, because it's on 1, it just equals root 2 on 2. If you do sine 45 from here, well, it has to be root 2 on 2 over 1 as well. So cos would be what? Well, cos would also be adjacent on hypotenuse or adjacent on hypotenuse. So actually at sine 45 and cos 45, they're the same value. And these are what we call exact values because we can get them exactly. Now, if you go on your CAS And we actually do keyboard, we do, what am I doing? Sine 45. Trig sine 45, you'll notice it's root 2 on 2 if you have it in real. Sorry, if you have it on standard. If you put it in decimal, it's that one. Now, it gives you an exact answer. Now, if you do like sine, if we change it back to it is sine 46, and you try and get it as a real answer, it's only going to give you sine 46, okay? Because it goes, well, I can't actually give you a value of that. That's as real as I can get it. Like this, you can actually get like a real ratio of what it is. Sine 46 is going to go, I can't tell you what it is. I can give it to you in a decimal, an approximation, but it's like an infinite number that never ends. So, you know, if you go back to standard, that's what's going to do that. All these other ones, you know, sine 47, like they don't get it. If you do sine 30 though, because 30, we can prove the exact value of that. That's a half. Also, sine 60, I can prove. That's going to give me a value, root 3 on 2. But these are the only ones that we can get real values for, because the other ones, you can't get an exact number, okay? We can't kind of use these proofs to get to there and use Pythagoras or use SOHCAHTOA to help us get there. So we can get decimals, and how they did that was literally by measuring the ratios of these sides. So if you do sine 45, you'll find that that is 0.72, which is the same thing as root 2 divided by 2. Whoops. So it's exactly the same number. So it's the exact number, where I can't get an exact number for other ones. So we've proved all of the exact values, which is basically 30, 45, and 60 degrees. Knowing that 30 comes from the same triangle with 60, okay, 30 and 60 come from the same triangle, and 45 just comes from the one triangle here. So just have a look at those again. Just going to quickly recap. You've got 60 degrees in each of the corners, 1, 1, 1. We half that, 1, a half. Think about Pythag, area 1, area quarter, area 3/4, root 3 on 2 is that length. From here, you now have your triangle where I can say, hey, sine 30 is a half on 1, so it's a half. Cos 60 is a half. Cos 30, sine 60 is the same thing. So you can see it's root 3 on 2. Down here, cos 45, sine 45, or it doesn't matter. So you can see why it's the same value. And that's root 2 on 2. So they're all the exact values. So when we come down here and we have sine 45, I think of that triangle, and sine 45 is root 2 on 2. And cos 45 is root 2 on 2. Now, that's it. So when we're trying to find proofs and exact values in here, that's what we're going to move to next. But before we do that, is there any questions? Thanks for help. All right, let's move on. Okay, we're going to move on to try and understand this. Now, if I do a 30-degree angle out from here, now I'm trying to pull on the prior knowledge that we've just gone through. So I hope you understand that. If you don't understand that, you should yell out. So we're going to try and actually use this to help us solve all this stuff in here. Now, if I've got this angle, which is really 30 degrees or pi on 6, when we think about it, guys, here, let's have a look at this. When we think about this, this is 30 degrees, and it's really opposite over hypotenuse. If this is 30 degrees in here, we know that the sine value is going to be opposite over hypotenuse, right? So it's this over that length. Now, if this is 1, really, sine is actually just this value. Okay, if I go, so really I can say that sine is actually an indication of how far off it is from the x-axis, which is the same thing as the y-coordinate. So I'm going to actually state that this is the value of, this is the value, the y value, the coordinate here is whatever sine 30 is. That's my y value, which in this case is 0.5. And my x value, well, wouldn't that be cos 30 adjacent over hypotenuse? So this length here is cos 30. Okay, so if that's cos 30, which is adjacent over hypotenuse, that's really just my length of x. And why we use the unit circle with 1 is because it's 1. So I can actually say that my cos 30 is my x coordinate. So the point here on the unit circle is actually showing me, which is root 3 on 2. That point there has a coordinate of root 3 on 2 and a half at 30 degrees. So that is the coordinate for 30 degrees or pi on 6. Now, if I go up to 60 degrees, just going to put 45 in, and then I'm going to put 60 in after this because it's halfway between the two. If I put in 60 degrees there, so that angle now is 60 degrees. If you think about that, that's going to have a triangle that is, just going to put in 45 here. So we're going to come back to that. This is 60 degrees. Now, if you look at this triangle here, that would be a right angle triangle there, right? So I can actually call that a right angle triangle. Don't forget, this is going to be 30 degrees in here, okay? So if you think about that, if that's the 30 degrees, well, this is the same triangle as this one. Now we know that this length, because if this is 1, this length has to be root 3 on 2, and that length has to be a half. Now don't forget, we've already defined, so I know that this coordinate here is going to be a half, and that is going to be root 3 on 2. And I know that this is my cos rule because cos is adjacent over the hypotenuse. And cos, because this is my adjacent, that has to be cos. So that's x. So cos 60 is that. So this is this, which is really the same thing as saying that the coordinate of this is cos 60 degrees, or I can say pi on 3. Sine 60 degrees or pi on 3. Now, I reckon there'll be a few people lost. If you're lost, please ask a question or just let me know. I can explain that again. But what I'm really trying to show you guys is a couple of things, is that my x coordinate is the cos, okay? Because it's adjacent over hypotenuse. Because your hypotenuse is 1, it really doesn't matter. So because I've got, so if I say cos 30 degrees and we're dealing with the unit circle, we know it is root 3 on 2 divided by 1, because that's, that is cos is adjacent divided by my hypotenuse. But because its hypotenuse is divided by 1, it just equals my, so if I take any angle on the unit circle and I do adjacent divided by hypotenuse, and if the hypotenuse is 1, I'm really going, well, adjacent divided by 1, well, anything divided by 1 is just itself. So therefore, it just equals the adjacent. Same thing with sine. If you take any unit on the unit circle and you say opposite over hypotenuse, well, because we're dividing by 1, it just equals my opposite. So sine theta will just be my opposite length. So sine theta is my opposite, is my opposite length. If you think about what your opposite length is in the unit circle, and I always come back and think about this in my head to try and remember what represents each axis. If I think of a triangle, that's a really bad. If I think of a unit circle, this is what I think of in my head to re-coordinate myself when I teach it each year, is I picture something like this. And I picture, okay, if this is my angle in here, opposite over hypotenuse. Well, hypotenuse is 1. So that means really this is equal to my sine theta, which is my y coordinate. Adjacent over hypotenuse is cos. So therefore that's actually equal to cos theta because my hypotenuse is 1. So it's the same thing. So therefore any point on the graph I think of as cos theta, sine theta. And that is an understanding that I really want you guys to try and understand. If you're not sure about that, please let me know. That's where we're trying to go with this. Any questions at all? Please let me know if you do. Okay, I'll move on. So if we've understood that, I'm going to come back to 45 a little bit later on. If I go all the way over here, right, and I take 30 degrees off from 180, this is where it gets really, really cool. And this is where you can get lost. So please let me know if you do. So if I go from here and I want to know, well, the value of this is what? Well, I can see off the coordinates that this has half. If you think about what angle this is, this would be 30 degrees off. This is 30 degrees here, right? That's 30 degrees here. If you think about what it actually is, so when we start measuring, we actually measure from here. This is where we call our start point. And this is really 0 degrees or...
So just quickly.
0 pi, yep.
So if the angle of the, like the triangle that you drew on the right, so if the angle inside was 30, then does that mean the coordinate would be cos 30 sine 30, and then if it was 45, it'd be cos 45 sine 45, and so on?
Yeah, exactly. So this coordinate here would be cos 45 sine 45. This coordinate here is cos 60 sine 60. But we know these exact values. So that's why we can actually say what it is. Where if I said it was 43 degrees, well, then it would be cos 43 sine 43. And remember on the calculator, if you do like sine 43 as an exact answer, well, you can't get that as an exact answer. It's a decimal. So that wouldn't be right. We're only looking at exact values. So if you did it as that, you don't get that. But if you look at like sine 45, right, like that gives you root 2 on 2. And hence the heading of this sheet is explanations and proofs of exact values for the unit circle. Does that answer your question?
Yeah.
Yeah, and you're pretty much spot on. Like you're confirming what your understanding is, and that's a really good question. Good clarification. You're spot on with that. So this is actually, can you see how this is, stick with me still, can you see how this is 150 degrees here? So we start here. Yep. And we move in a anti-clockwise direction. So as we move that way, as we move this way around the unit circle, we're going to add on positives. We can also start here and move that way and make it negatives degrees. So as I go here, that's 30 degrees. That's 60 degrees. If I come all the way around here, that's going to be 150 degrees. Okay. So what I'm going to call this here, and if you think about what the coordinates for this would be, well, if this was a 30-degree triangle, this would be opposite. We know that's a half, right? So we know that's a half high. And if you think about the length of this, that's going to be root 3 on 2. However, we're on a Cartesian plane here, all right? So that's my x, that's my y-axis. So this was positive root 3 on 2. So this has to be negative root 3 on 2. So the coordinates of this point is negative root 3 on 2 and upper half because it comes from the same 30-degree triangle. And this is, as we said before, the coordinates of this is going to be cos 150 degrees, or we can call it 5 pi 6. And sine, I'm going to run out of room, 150 degrees or pi 6 as well. Okay, So that's what we're going to be looking at. So that is the coordinate there. Similarly, if I take this axis and I go up 60 degrees, right? Because don't forget, we know 60 degrees, that would be 30 degrees there. So that's a half there. Well, we know that the coordinate of this is going to be negative a half for the x. And for the y, it's going to be root 3 on 2 because we're still positive. So we know that the coordinate of that is going to be not, well, 60 degrees off here. Okay, so that's 60 degrees there. So it's 60 degrees off 180, so we know it's 120 degrees. So we know that is going to be cos 120 degrees, or 2 pi and 3. Sine 120 degrees, or 2 pi on 3. And that's my coordinates for those. So my x is always my cos value, and my y is always my sine value. And that's how we get it. So let's continue with this, okay? If we keep on moving around, and if we keep on moving around and we come 30 degrees down from here, well, if we think about what this actually is here, well, I know that this value here is going to be cos, because we've actually came 30 degrees down from here. So that's going to be 180 plus 30, which is going to be 210. So that's going to be cos 210, or it's going to be 7 pi on 6. Sine 210, or 7 pi on 6. But let's think about what this is actually going to be as a coordinate. Now, don't forget, cos is your x coordinate. Well, again, if you think about what triangle this is going to be a half here. So, and this is going to be root 3 on 2, but it's going to be negative because it's in a negative direction. So the coordinate is going to be negative root 3 on 2, comma, negative a half, because we've came down. So if you actually go to your calculator, and if we put in cos 210, and we want to look at it as a real answer, it's negative root 3 on 2, because it comes from that same triangle. It's the 30-degree triangle, you know, and it's came down. The length of cos is negative root 3 on 2. So sine 210 would be negative a half, because it's gone all the way down and it's actually now negative a half this length. So if we then look at over here, and we keep on going right around the circle, and we go to there. So we've gone 360 degrees, and then we're coming back 30 degrees. Now, if you think about that, the length of cos is going to be the same as cos 30 degrees. So 330. So that would be, the point here would be root 3 on 2. However, down would be negative a half. So the coordinates for that would be cos, that's a really bad C, cos, what are we looking at, 330 degrees? Or I can say 11 pi on 6. Comma, sine 330. I'm just going to do 330 or 11 pi on 6. And that's where we can get those measurements from. And that's the coordinates there. So let me do it this way. If I go 30 degrees, that's my coordinates. If I go 120 degrees, that's the value of cos and sine. If I do, then I do 210 degrees, that's the value of cos and sine. If I go 330 degrees, that's the value of cos and sine. If I come around again, that's 360 plus 30. 390 degrees, that's the same thing. That's the value of cos and sine. keep on going around to here. So it's 360 plus 150. We're looking at, what are we talking about then? 410, I think off the top of my head. No, that's not right. 510. That's the value of these two. So if we put in sine 510, so if you actually think of like it as 360 plus 150 degrees, right? That's a half, because you think about sine, it's still a half there, which is going to be 510, right? It's a half. So it doesn't matter how many revolutions you do, because you're just going to keep on going around and around the circle, and you can keep on adding up these. So it can also be, you can do another revolution in here. So you could add another 360 in here. So it doesn't matter how many revolutions you do, you just keep on going on. So really what I've done here is I've started here, I've gone 360, another 360, another 360 right around, and then 150, and I'm asking you what sine is. Well, sine here is the value of opposite over hypotenuse. So it's this height, right? Because I can draw that triangle. So the height of it is a half, okay? Cos, the same angle, would be root 3 on 2. So it's still why it's a half. So what is, let's just figure out what angle this is. Just to sort of show you guys. So what are we talking about? We're talking about, 1230. So if I do cos 1230, that's going to be adjacent over hypotenuse. So it's going to be root 3 on 2. Now, even though it's that angle there, we make triangles in here to figure out what the value is. Come on, whoops, might help if I put an S in. There we go, negative root 3 on 2, because that's where we are there. Add another 360 degrees onto that. That's going to take you to 90. Cos would still be negative root 3 on 2. And sine would have to be negative a half here, because I'm actually at that point. Whereas if I took 60 degrees off, sine would then become positive, because you've gone back 60 degrees. We're up there, so we've gone back 30 and 30. So that would be 30. So you'll notice sine will now be positive. And that's how the inner circle works. And that's how we get the values. So really all we need to do now is just calculate the rest of these values. So we can actually look at the 60 degree one, which we haven't done. Okay, so if we take a 60 degree triangle and we know that it's going to be halfway, I always use half, we know it's going to be halfway along here. So that's going to be 60 degrees from there to there is going to be 60 degrees. Okay, if you think about the degrees of this, that's going to be 180 plus 60. So it's going to be cos 180 plus 60 is 240. Or I could call it pi on 3, 2 pi on 3, 3 pi on 3, 4 pi on 3. And the y coordinate would be sine 240 or 4 pi on 3. Now the actual coordinates for this would be, well, if you think about it, that's going to be a triangle here, right? We know that's 30 degrees in here. That's going to be a half. If it's opposite 60, that's going to be root 3 on 2. Sine is your y, so that's going to be root 3 on 2. It's going to be negative root 3 on 2. And your x coordinate here is going to be cos, and that is going to be negative a half, because this is the origin. Gone negative a half and we've gone down. The next point we can look at is here. And we go across to a half, because we know half's always in there. And then you've got this kind of triangle in here again. So you've got, this triangle is the one that we're trying to look at now. This right angle in here. We know that this is going to be 60 degrees, okay? So this length here is going to be root 3 on 2. It's still going to be negative, and that's your y coordinate. So it's going to be negative root 3 on 2. But your x coordinate is actually going to be a half, and it's positive a half. So I know cos is my x, so it's actually cos, what do we got? 360, take away 60 is going to be 300. or I could call it 2 pi, that would be 6 pi and 3, 5 pi and 3. Take away pi and 3. And sine, it'd be either 300. Now, it doesn't have to actually be 300. It can be adding on, a full revolution of these, which we'll get to a little bit later, as we sort of touched a bit before on. And that's your full solutions there. So now we've got our values. So from there, what we can see is that if I do 60 degrees, that's the same thing as 120 degrees, except I know there that my x coordinate is going to be negative. My y is still going to be same positive. And if we know cos, so when we come to here, we look at 120, that's the same thing as 60. My sine is my y value. Okay, and I know my cos is my x value. So if I think about it, once I know I get over that 120, once I get into this quadrant from 120 up to 150, even 180, I know here any value from 90 to 180, I'm going to have a positive y value with a negative x. So in this quadrant, I know that sine will be positive and cos will be negative in this quadrant, right? Tan is a value of sine, is a value of opposite over TOA, opposite over adjacent. So it's actually sine divided by cos. So if I go sine divided by cos, positive divided by negative, it's going to be negative. In this quadrant here, I know sine is going to be positive. I know cos is going to be positive because it's positive and positive. So that's anywhere from 0 to 90 degrees, or, repeat that again, 360 to 400 and, add another 90, 450 would also be that. And because tan is opposite over adjacent, it's positive divided by positive, I know all of them are going to be positive in here. So all are positive in here. Only sine's positive in here. If we look at this quadrant, wow, down in this quadrant, we know that sine is going to be negative. We know that cos is going to be negative. A negative divided by a negative, though, for tan will be positive. So we know that tan is positive in this one. And over here, we have sine is going to be negative. Cos is going to be positive. That means a negative divided by a positive is going to give you a negative for tan. So cos is only positive. And some of you may realize this is how we come up with a thing called SACT, S-A-C-T. Sine's positive here, all are positive there. Cos is positive here, only tan's positive there. Some people remember this as a little thing just to remember what is positive, what isn't. I personally just try and think of the inner circle and where I am. And I think of, if I'm over here, I know y, which is sine, is positive, and cos, which is x, is negative. If I'm in this quadrant, I think, well, sine and cos is negative. So I know that tan will be positive because a negative divided by negative is a positive. If I'm in this quadrant, I think of, cos would be positive and sine would be negative. Sine divided, positive divided by a negative is negative. So I know cos is the only thing positive in here. Up here, both of them are positive. So when I'm thinking of that, it's really about finding similar ones. I know 60 degrees gives me the same triangle as 120. I know the sine is the y value, so that's going to be root 3 on 2. And I know that cos is going to be the same value as 60, is 120, but it's going to be negative. Because if you think about it, your 60-degree triangle is the same thing as your 120-degree triangle. 60 degrees there, 60 degrees off there. It's the same triangle. It reaches the same point. Over here, we've got a half root 3 on 2. So that means that has to be negative a half root 3 on 2. We just came across. If we look at the other 60-degree triangle, it's going to be 180 plus 60. Right? If we keep on working through that, that's going to be your 240-degree triangle. Now, I know sine here is going to be negative root 3 on 2. And I know cos is still going to be negative over here. And then when we get to our last 60-degree triangle, which is 300 degrees, because 60 degrees off that, I know that sine is still going to be negative because it's my y coordinate. But I know cos is now going to be positive. So I can find all these similarities because that's my 60-degree triangle. So I've just basically gone from here to here to here to here. Notice they both come out half. They both go up √3 on 2. And these go down √3 on 2. And that's why we're just looking at those. If you think about it, 60, 120, 180 plus 60 plus another 60 will take you around. So if I look at my 30 degrees off 0, when I'm looking at sine again, I'll look at it from here. 30 degrees off there would be 50. So I know when I'm looking at 30 degrees off 180, that sine value would still be positive in here. So that's going to be a half. That's a half. And we know this is going to be negative √3 on 2. Similarly, I can then go to 180 and add 30 degrees on. That's going to give me now negative a half. Negative √3 on 2 still for my x coordinate. So what I looked at there is I went basically at 180, add on 30, take away 30. Take away 30 is what I did first. So no, that's going to be the same as that one. It's just reflected. And then we've reflected it here in the x. So we've got the same point and coordinate. 360, take away 30. It's going to be 330. So my value there is going to be the same thing, which is a half. It's going to be negative a half because we're down, but it's going to be positive √3 on 2. So that's moving in the positive direction. Moving in a negative direction, if I went negative 30 degrees, I'm going to end up here. Negative 30 degrees, I would have negative a half and positive √3 on 2. Similarly, if I went right around to negative 180 and then added 30 degrees back on, so if I start from here and I go, hey, all the way around to 180, but then come back to 150, I'm then going to have that same triangle. That's going to be a half. This is going to be negative √3 on 2, and negative a half. So we can actually start there too. So it's going to be negative a half, negative √3 on 2. Then I go to 180 and I add another 30 degrees on. That's going to be a half. That's still going to be negative √3 on 2. Because what I've done there is I've gone 180 plus another 30 degrees. And that's how we get our values there. So I can see that's √3 on 2, negative √3 on 2, that's a half. Then keep on start here, go around all the way negative 360, come back 30 degrees. Well, that's the same as your other point. So I know that's going to be a half and positive √3 on 2. And we can do this for all of the angles. And I would encourage you guys to fill this out. We can also do it for all the 45-degree angles as well, okay? So obviously 45 is going to be a bit easier. We know that the point here, well, 45, we know it's √2 on 2, and both of them are. So remember it goes cos, that'd be pi on 4 or 45, and then you've got sine. So cos, if we have 45 over here, okay, that is going to be negative √2 on 2, because it's your x-coordinate first, which is cos, and then positive √2 on 2. And that's going to be 3 pi on 4, or you guys can figure out the degrees as well. All right, and down here, obviously they're both going to be negative, okay? And over here, your x would be negative, or cos would be, sorry, your cos would be positive over here, and your sine would be negative. So when we get to our calculations and we look at 45s, over here on 45, I know that sine would still be positive, √2 on 2, but the cos would be negative because that's your x value. When we get to 225, I know they're both going to be negative because we're down in that, if you've got the unit circle, we're down in this quarter. And over here, we're over here. So I know that the x would be positive, which is cos, and the sine would be negative. And that's it. Now we just got to figure out our zeros. Well, if you think about our zeros, if you start here, and if you think about a triangle, we said sine is our y coordinate. Well, y there is 0, and cos there would be 1. So when I say cos 0, that's 1, and that would be 0. And that's why, because that's where we start. So at 90 degrees, that's here, our y would be 1 and our cos would be 0. So sine 90 is 1 and cos is 0. And this is why it never goes greater than 1 or 0 for sine, because it's not the hypotenuse length. So if you look at sine 90, it's 1, cos 90 is 0. Oops, that's 0. Cos 90 is 0. There we go. So 180, sine would then be 0 again. And cos would be then -1, because you're around here, right? Then at 270, well, sine would be -1 and cos would be 0. And then when we get to 360, well, we're back at the start again. So we know that sine is 0 and cos is 1. If we look at our negative numbers for that, 0, sine would be 0, cos would be 1. Ugh, what's that line? There we go, because you're here. Whoops, there. To be. When you go down to -90, we know that sine's going to be -1, cos is going to be 0. -180, we know that cos is going to be -1, sine is going to be 0. When we get to 270, we know that sine is 1 because it's y, and cos is 0. And that's how we can figure out all our angles. Now, lastly, we said that tan is opposite over adjacent, so it's really sine over cos. And the reason for that is because, as we said, if you think about it, when we talked about this, we're saying, hey, this is sine theta, and this is cos theta. And we said that this is, tell me I lost all that. No. So we've got sine theta and cos theta. And we also know that this is theta in here. So tan is opposite over adjacent. So it's sine divided by cos. That's why tan equals sine divided by cos. 0 divided by 1, 0. This divided by this. Now, don't forget, you can just flip that and multiply. So your 2's are going to cancel out. It's going to be 1 on root 3. That's why we did sine and cos first, because of tan. Root 2 on 2 divided by root 2 on 2. You can flip that. That's actually going to be the same thing divided by the same thing, is 1. Root 3 on 2 divided by a half, which is really root 3 on 2 times 2 on 1, is going to be root 3. 1 divided by 0. If you guys recall, you can't divide by 0. That's going to be undefined. So you can't divide by 0 there. Root 3 on 2 divided by this one is actually going to be negative root 3. This divided by that's going to be -1. That divided by that is going to be negative root 3, and it keeps on repeating itself in this pattern. And why it will repeat itself is because if you think about sine tan 30 should be the same angle as tan 150. Should be. I stuffed something up there. I did stuff that up there. That should be 1 on root 3, -1 on root 3. And because, they're the same triangle. So 60 should be the same angle, same as 120. But why tan's positive here is because it's sine divided by cos. Sine and cos are both positive here. So that means tan's positive. Sine's positive, cos is negative. Tan needs to be negative. Down here, they're both negative, so tan will be positive. So you're going to find it's the same thing. 0 divided by -1 for 180 will be nothing. But now, because you've got the same thing, so it's the same as this, but these are both negative that we're dividing by, it's going to be positive. And here, what do we got? This is -2. So it's going to be, it's the same thing divided by the same thing, but they're both negative. So that's going to be 1. That's the same thing as what we divided with over here. So that's going to be positive. That's going to be undefined, and so on. Now it's going to be negative divided by positive, so it's going to be negative. And we don't like surds really on the bottom, so that could actually be 3 root 3 on 3. And that one is undefined. So you actually get these undefined things. No, that's not right. Sorry, that is 0. And that's the values for that. I'm not going to worry about this stuff. Don't worry about that. And that's pretty much it. Let's stop it there.